Hello my dear students, in this video I would like to explain the transformations on functions. In this case we're going to explain the horizontal and vertical shift. So suppose you have a function y equals f of x. This function y equals f of x is your basic function. So to have a vertical shift, you will be adding or subtracting a number from your function. So when you have a function y equals f of x plus c, this transformation is a vertical shift c units up. When you subtract c from your function, so y equals f of x minus c, the transformation you have is a vertical shift c units down, c units downward, or c units down. Now, when you want to have a horizontal shift, we have to substitute x by x plus 8 or x by x minus 8. So you have your function now y equals f of x plus 8. You have a horizontal shift a units to the left. And you have a function y equals f of x minus 8. Then you have a horizontal shift a units to the right. So let's see then the first exercise that we're going to do based on, this previous explanation. So they give us a function that is y equals absolute value of x, and they ask you to get the function when you shift the graph 8 units upward. So to shift 8 units upward, we have to be adding the magnitude of the shift to your function. So we basically will add 8 to absolute value of x. So y equals absolute value of x plus 8 is the graph of y equals absolute value of x shifted 8 units upward. In the other exercise, they say, well, now what is a function if we get a graph of y equals the square root of x and we shift it 4 units toward the left, and we shift the graph 4 units to the left. So remember what I was explaining here at the beginning. To have a horizontal shift toward the left, you will substitute the x of the function by x plus 8. So by x plus the magnitude of the horizontal shift. So in this case, if my horizontal shift is 4 units toward the left, we will substitute x by x plus 4. So my function will be y equals a square root of x plus 4. A square root of x plus 4. This gives you a horizontal shift 4 units toward the left. The next exercise we have here is to match, the graph with the function. And in this case, when we look at this function, if we remember, the library function, we immediately recognize that the basic function here is the function square root of x. And that function square root of x, how it was. If you remember from the class, I said in classes that the function is passing to the point 0, 0, to the point 1, 1, and to the point 4, 2. So the graph of a square root of x is a graph that looks like this. This is y equals a square root of x, right? And the characteristic points that we have in this case are 0, 0, 1, 1, and 4, 2. Now, where is this point in the new graph? This point here is at 1. So this point was moved one place toward the right, was moved one unit toward the right. So if the point 0, 0 was moved to 1, 0, so was moved one unit toward the right, there was here a horizontal shift. There was a horizontal shift one unit to the right. And to get a horizontal shift one unit to the right, we substitute the x by x minus 1. So that means that now instead of y equals a square root of x, we will have y equals a square root of x minus 1. So the right answer here is this one. So the function that corresponds to this graph is y equals a square root of x minus 1. This is a horizontal shift one unit to the right. Now look at this exercise, very interesting. They say that the point 2, 4 is on a rectangular coordinate system, so we will plot the point 2, 4 here. So 2, 4 is a point that will be here. And they say that then find the point on the graph of the given function, that is y equals f of x plus 2. So we have to go and identify what was the transformation that they did in this case. So they have clearly substituted x by x plus 2. So it's clear that this transformation was a horizontal shift two units left. So if I move this point 2 units toward the left, it's like subtracting 2 from the x coordinate of the point. So 2 minus 2 is 0. So the new position of this point would be 0, 4. So the point 2, 4, if the transformation is y equals f of x plus 2, which is a horizontal shift 2 units to the left, goes to the position 0, 4. They give us now the same point 2, 4, but now a different transformation. So again, we are graphing here the point 2, 4. This is x and y. 1, 2, 1, 2, 3, 4. So 2, 4 will be here. Let me extend this graph a little bit. So 5, 6. And then they say that we want to find the position of the point when the transformation is f of x plus 2. So f of x plus 2 means that they have done here a vertical shift 2 units up. So if there is a vertical shift 2 units up, this point that was in 2, 4, what are you doing? You are adding 2 to the y coordinate. So you will be adding 2 to this coordinate. So this point will go from 2, 4 to 2, 6. So the point will go up 2 units and its new position will be 2, 6. Because the transformation done was a vertical shift 2 units up. Now, once you understand, how to apply the shift up, down, right, or left, then we're ready to do it with a function. So look at the function given. It is clear here that the basic function is the square function y equals x squared, right? Or f of x equal x squared. And then they say that the function is f of x equal x squared minus 2. So we have to say what was the transformation that was done here. Of course, this 2 subtracted from x squared is a vertical shift 2 units downward. Now, how is the function f of x equal x squared? If you remember that function, this was a function that was passing to the point 0, 0, 1, 1, minus 1, 1, was passing to the point 2, 4, minus 2, 4. I need really just with 3 points would be enough to get a graph. So I know this point is 0, 0, the vertex. There's one point here in 1, 1, and this point over here is in minus 1, 1. And then if we draw the graph of the function, the graph is a parabola. I will try to do my best to get a parabola. So it is like this. So this one is the graph of the basic function f of x equals x squared. But really the function we want to get is just the function f of x equals x squared minus 2. So that means that now we will be subtracting 2 to get the vertical shift 2 units downward from the y coordinate of each of the points. From the y coordinate of each of the points that are in my graph. So if I subtract 2 from this point 0, 0 from the y coordinate of 0, 0 is 0 minus 2, right? So you will be subtracting 0 minus 2. So remember this point is 0, 0, right? Let me just clarify this. Okay, so 0, 0. So what are you going to be doing? You will be subtracting 2 from the y coordinate to get your vertical shift. So you subtract 2 from 0 to get a new position for this point. That would be 0, minus 2. So the new position of the point 0, 0 would be 0, minus 2. Now the point 1, 1, well, would be subtracting 2 from the y. So we will be subtracting 1 minus 2. And when you subtract 1 minus 2, this point goes from 1, 1 to 1, minus 1. You can do now the same here. You have this point that is at negative 1, 1, so you are subtracting 2 from the y coordinate to get your vertical shift 2 units downward, and this point goes from negative 1, 1 to negative 1, negative 1, which is going to be here. Well, we know that these other points so are 2, 4 and minus 2, 4 would be this one. So if now I do the same, if I subtract 2 from the y coordinate of those points, you know, 2, 4 goes to 2, 2. So the point 2, 4 goes to 2, 2, which is going to be here. And minus 2, 4, subtracting 2 from the y coordinate, we go to minus 2, 2. So your graph will look like this now. Let's try to do my best to get a parabola. Doesn't look too much like a parabola, I'm sorry. And then this is my function f of x equals x squared minus 2. Right? So this is the vertical shift 2 units downward. All the points on the graph have been moved down 2 units. Look at this over now. This is f of x equals x plus 5 squared. So again, it is evident that the basic function here is f of x equals x squared. We know what are the points, on this graph. So we have 0, 0, as we mentioned before, 1, 1, minus 1, 1, 2, 4, and minus 2, 4, right? So again, 0, 0, 1, 1, minus 1, 1, 2, 4, minus 2, 4. But now, of course, the graph looks like this. Again, I will try my best with a parabola. So this one is y equals x squared. But we want to get y equals x plus 5 squared. So what transformation was done here? Of course, it's a horizontal shift. But now, how many units? 5 units. In what direction? The sign is positive, so it's to the left. So we have a horizontal shift, 5 units to the left. So we have to move every single point on my graph toward the left. We create our new rectangular coordinate system here. Then 1, 2, 3, 4, 1, 2, 3, 4. This is y, this is x. Minus 1, minus 2, minus 3, minus 4, minus 5. So here is minus 4. And then now minus 1, minus 2, minus 3, minus 4. Right? So what are we doing? We're moving all the points 5 units to the left. So you're moving the point 5 units to the left. This point, that is at the origin, 0, 0. When you subtract 5 from the x coordinate, because to move it toward the left, you have to subtract from the x coordinate. You subtract 5 from the x coordinate. This point goes to minus 5, 0. So the new position of the point will be here in minus 5, 0. Of course, now we do the same with the other points. So we will be subtracting 5 to the x coordinate of the point 1, 1. So 1 minus 5 would be minus 4, 1. So this point will go to minus 4, 1. So the point that was in 1, 1 go from 1, 1 to minus 4, 1. And the point that is in minus 1, 1, when you subtract 5 from minus 1, you get minus 6. So we go to minus 6, 1. Now, you have the point 2, 4. When you subtract 5 from the coordinate x of this point, so 2 minus 5, it goes to minus 3, 4. It goes to minus 3, 4. So minus 3, 4 will be here. And when you subtract 5 from the x coordinate of this point, there is minus 2, 4. Minus 2 minus 5 would be, in this case, minus 7, 4. So this point would be here in minus 7, 4. So that means that your new graph will be passing through the points minus 5, 0, minus 4, 1, minus 3, 4, and also to minus 6,1 and minus 7,4. So this one is going to be your graph of y equals x plus 5 squared. If you want to double check if it's true that the graph is correct, you just pick one of the points, whatever point you want, this one. So the point minus 7,4, you say is minus 7,4 on the graph of the function? Easy. Let's see. Minus 7 is x and 4 is y. I will get a function that was given, that was y equals x plus 5 squared. I will substitute the x by x value, so y is equals, then x we said that is minus 7, so it's minus 7 plus 5 squared. So minus 7 plus 5 is minus 2 squared, and minus 2 squared is 4. And look at this is 4. So yes, this point minus 7,4 is in the right position. I have one last exercise here. In this exercise combine two transformations. So this combine a horizontal shift 4 units to the right of the quadratic function and a vertical shift 5 units up. So the first that I'm going to do here is to move my graph toward the right 4 units. So remember that this function passed to the points we said 0, 0, 1, 1, minus 1, 1, 2, 4, and minus 2, 4, right? And well, the graph is more or less like this, right? It's a parabola. So this is the function y equals x squared, the basic function. Now there are two transformations here. There is here a vertical shift five units up, and we have a horizontal shift uh, 4 units to the right. Remember that when the sign is negative, here in parentheses, the shift is to the right, 4 units to the right. So I will build two graphs. I will do one transformation first, either or, and then over the new graph, I will do the second transformation, right? So let me put some coordinates on my axis. So let's first do the horizontal shift 4 units to the right. So remember that we have the points 0, 0, which is this, 1, 1, 2, 4, minus 2, 4, and minus 1, 1, right? So we start moving all these points 4 units to the right, 0, 0 goes to 4, 0. I am just making the horizontal shift 4 units to the right. It goes to 4, 0. The point 1, 1, adding 4 to the x coordinate 1 goes to 5, 1. The point that is in minus 1, 1, adding 4, minus 1 plus 4 is going to be 3, 1. The point that is in 2, 4, adding 4, go from 2, 4 to 2 plus 4, 6, 4. So we'll be here. And the point that is in minus 2, 4, adding 4 to minus 2 goes to minus 2 plus 4, 2. 2,4. So my graph after the shift is like this. This is f of x equals then x minus 4 squared. Now, of course, this line must be passing through this point, right? Now, what are we going to do? On this graph, we're going to do the vertical shift 5 units up. So we do the vertical shift, not using the graph of the basic function, but using the graph of the function that have already the shift. So let me add some coordinates to this graph. This is 5, 6, 7, 8, and then 1, 2, 3, 4, 5. This will be 5. So 6, 7, 8, 9. It will be 10 here. 11. So what are we doing? Now we're moving this point 5 units up. So the point that was in 4, 0 when we add 5 to the y coordinate goes to 4, 5. Go to 4, 5. So the vertex is now in 4, 5. Now this point that is in 5, 1, when we move it 5 units up, so adding 5 to the y coordinate 1 goes to 5, 6. Go to 5, 6. So this point is 5, 6. This point that is in 3, 1, by adding 5 to the coordinate 1 of y, go to 3, 6. This point that is in 2, 4, by adding 5 to the y coordinate, that was in 6, 4, not in 2, 4. That was in 6, 4. By adding 5 to the y coordinate, go to 6, 4 plus 5, 9. To 6, 9. So 6, 9 will be a point around here. So this one is 6, 9. And this point that is in 2, 4 by adding 5 goes to 2, 9. So 2, 9 will be this point. And now we're ready to graph. So how it's going to be the graph? It's going to be a parabola passing to these new points. So now the graph is the graph of finally f of x equals x minus 4 squared plus 5. This is the graph of f of x equals x minus 4 squared plus 5 with a horizontal shift 4 units to the right and a vertical shift 5 units up. So these are the exercises that I have for you. So I want to go up and summarize again the transformations. So remember that today we did the horizontal shift and the vertical shift. I just gave you different exercises starting with very easy exercises. But I want to remind you that if we have a function y equals f of x, when you make a vertical shift c units up, what are you doing is adding c to the function f of x. If you make a vertical shift c units down, what are you doing is subtracting c from your function f of x. Now, when you make a horizontal shift a units to the left, you substitute the x of your function by x plus a. When you make a horizontal shift of your function a units to the right, you replace the x of your function by x minus a. These are the vertical and horizontal shift. Next class, I will be explaining at least one more example about vertical and horizontal shift, and then we're going to see reflections, and we're going to see the stretch and compress. Thank you for the attention, and I hope that this video is going to help you to understand better, this topic.